Game Development with Delphi. Hey everyone, this is Eli M. from FMXExpress.com. Just some information about me before we get started. I have deployed over 300 mobile games across Google Play, Apple App Store, Amazon App Store, and Samsung apps. I have also aggregated over 80,000 plus Flash games to 120 plus million players worldwide, reaching over 210 plus million gameplays. And with FMXExpress.com, I have reached over 400,000 developers with hundreds of tips and tricks for FireMonkey. We are going to be covering 4 different games built using the FireMonkey framework in Delphi with Object Pascal. The games run on Android, iOS, Windows, and Mac OS X using a single UI and single codebase. On Android and iOS, FireMonkey uses OpenGL ES. On Mac OS X, it uses OpenGL, and on Windows, it uses Direct2D or GDI+. There are 2 versions of the games available. The first version contains the gamepad and an SQLite-based high score system. The second version compiles on the Delphi Starter Edition. It uses an INI file for the high score system, and the gamepad is disabled. The games are also available in C++ for C++ Builder. The games themselves are based on classic arcade game mechanics and include Alien Invasion, Mars Rocket, Rocket Ship Delta, and Space Rocks. Alien Invasion features a grid of enemies which fall towards the player that the player must destroy. Mars Rocket features an inertia-based rocket that the player must successfully land. Rocket Ship Delta is a side-scrolling game where the player must defend a planet from attack. And Space Rocks has a group of asteroids that the player must break up and destroy. Each game has its own mechanics, but are all based around the same architecture. We will highlight each individual game and its unique mechanics one at a time. During each highlight, we will talk about 2 different architectures or framework features that are leveraged throughout all 4 games. The architecture and framework features we will be using are T-Rectangle as an image container, using frames for UI, utilizing the motion sensor, saving high scores using SQLite and live bindings, simple object pooling, sprite sheet animation, app tethering, and cross-platform sound. The games are built using a rapid application development style designed for fast iteration and quick time to market. The games were designed around the idea of a game loop, which is a heartbeat for the game. There are other ways to build a game, like using a message system or using threads, but in this instance I simply used a T-timer control set to 36 milliseconds. Most of the actions within the game take place during the game loop. The player's actions change various Boolean variables, and those variables are used during the game loop to affect the game. If the code within the game loop takes longer than 36 milliseconds to execute, the player may experience lag, so keep that in mind when you are optimizing the game loop. Within the game loop, it processes game events like game over and level complete, the player inputs including the accelerometer, explosions, and projectiles, enemy movements and events, and power-ups. Finally, it handles collision detection for all entities and looping the music. Let's look at the game loop code for the first game. So here I have the game loop event defined in the Delphi IDE. We've got the local variables at the top. We have a debug section here that we use to calculate the time that it takes to complete the game loop. We have the game over section here. We have the level complete section, and we have the accelerometer is processed right here in this section. We handle player movement and firing in this section. Then we handle the explosions list, and then we handle the player projectile properties in this section. We've got the projectile list, and it goes through, checks all the enemies against all the projectiles, does a collision detect. And then we also, this is Alien Invasion, so it has a wall list, and we check the walls and the collision and the projectiles using this collision detection to intersect rect. And we also check the collection list for the same thing to see if it collides with the projectile. And moving on to the next section, we handle the enemy movement and enemy firing by looping through the enemy list, and it does various player hit events here. It checks the walls to see if they have been hit by the enemies, and it decides whether it needs to fire an enemy projectile. And if the enemy is hit, it creates an explosion graphic around it, and then the enemies are also deleted here or removed if they have been hit by any of the player projectiles previously. And Then moving on to the next section, there is the enemy projectile list, which it loops through. It checks the walls to see if they get hit. It checks the player to see if it gets hit. And then in the next section, we spawn the enemies. There's a flying saucer that randomly flies back and forth across the screen, so we decide to spawn the enemies in this section. In the next section, we go through the collect list and move the collection items around and remove them if they have been hit or something along those lines. And finally, the next few sections, we can spawn the collectible item, and then in this game it's got a grid of enemies, so we move the grid back and forth in this section. Finally, we've got the music loop, which is handled here, and then at the bottom we have the end of the debug section where it calculates the millisecond time from the top and then at the bottom, and displays that in a label there at the end. And so that's the game loop code. You could refactor the game so that the game loop is within a thread, or there is another trick you can use with a game loop where if it takes longer to execute than the time until the next frame, in this case 36 milliseconds, you pause the game loop execution and resume it where you left off in the next frame. So if you were leaping through the explosions and you reached 36 milliseconds, you would record where in the loop you were and then exit the game loop at that point. During the next loop execution, you could start up again at the same loop increment instead of starting over at the top. Both of these types of optimizations can greatly increase the complexity of the code though. There is an if-def setup called debug, which is currently enabled. When enabled, it displays the current cost of each game loop in milliseconds on a T-label. You can disable it in code before deploying the game to the various app stores. All 4 games can be controlled via the keyboard, mouse, touchscreen, or accelerometer, depending on what input types your device supports. The possibilities for expanding and mashing up these games into new games is almost limitless, so I am also going to share with you some ideas with each game so you can jump in and start modifying the games right away. The first game we are going to talk about is called Alien Invasion. Alien Invasion is a classic arcade-style game which features a grid of aliens that move in sync back and forth across the screen. They fire projectiles at the player, who is at the bottom of the screen. On each trip back and forth across the screen, they start moving faster and faster. There are 4 shields near the bottom of the screen that the player can hide behind, but they have a limited number of hits they can take before each shield is exhausted. The player can only move back and forth at the bottom of the screen and fire projectiles upwards. Only one player projectile can be active at a time, so if you miss, you must wait until the projectile leaves the game space before firing another projectile. There is also 2 special bonuses that exist within the game. One is a random spaceship which moves across the top of the screen, and then second is a points power-up that randomly moves around the screen. So here I have Alien Invasion open in Delphi, and I just want to show you real quick this asset layout container, which contains the enemies, the saucer projectile, the enemy projectile, the player projectile, the bonus points object, the wall, and the health. And we're going to talk about those a little bit later, but I just wanted to show you those in this game first. Alright, so now I'm going to run Alien Invasion so you guys can see how it plays. I'm going to move it down here. Play, continue. And so we've got the enemy grid there. They're moving back and forth. I'm firing my projectiles at them, and I'm going to clear out all these enemies. So we got the walls. I can destroy the walls or shields. I'm going to clear out all these enemies, and then you guys can see the level complete screen at the end of it. So I've almost got them all destroyed. Oh, a few guys left. Last guy. Oh, level complete. I'd like to share a screenshot of an early version of Alien Invasion so you can see it in its skeleton form, before the graphics were applied. You can see how the T-rectangle is used. So here we've got the enemy grid here, that's each one of those is a T-rectangle. We have the enemy projectiles, we have the wall shield graphics there, we have the left and right button, we have the player, we have the player's projectiles, and we have the fire button. We are going to cover the basic building blocks of how I put the games together using the Form Designer and the various FireMonkey controls and components. The most basic building block is the humble T-rectangle control. Let's talk about using the T-rectangle as an image container. The T-rectangle control is the cornerstone of most of the objects within the games. This includes things like the menu buttons, the player character, the enemy characters, and the various projectiles and explosions within the games. T-Rectangle is a very versatile control. I chose T-Rectangle because it is able to display a bitmap like a JPEG or a PNG, and it is more lightweight than T-Image. The dimensions, rotation angle, and position of the T-Rectangle can be easily accessed when building collision detection as well. You can modify the look of the T-Rectangle control using the fill and stroke properties. The fill property is the face of the T-Rectangle, and the stroke property is the line around the edge of the T-Rectangle. Setting the T-Rectangle stroke kind property to none will turn off the line around the T-Rectangle. The T-Rectangle fill kind property can be set to bitmap, which will paint the face of the T-Rectangle with the bitmap property you set up as a T-bitmap brush. The T-bitmap brush has a wrap mode property which controls whether the bitmap will be tiled or stretched to cover the face of the T-Rectangle. In most cases, I use the tile stretch setting for the wrap mode within these games. Alright, so I'm going to select the T-Rectangle here. This is set up as enemy, and I'm just going to show you some of the properties we have here. We have the fill property right here, which has the bitmap brush. It has the bitmap on it, and I can show you that bitmap setup is right there. You can load and save bitmaps from there, or PNGs or JPEGs. Here's the wrap mode property. It's set to tile stretch. The kind property here is set to bitmap, and then you can also see that this T-Rectangle has a height property. It has an opacity if you want to change that. It has a rotation angle. It has a position property that you can change, or that gets changed within the game within code. And here is the stroke property that I talked about, where you can configure the line. You can set it to solid or dash in this case. As you can see, the dash is set around here, so that, and that gets set to none at runtime, but for design time purposes it allows you to see what objects are in the asset layout there. And then there's also the width property down here at the bottom, and that is lots of the properties of the T-Rectangle. Collision detection for the T-Rectangle objects is handled in the games using the intersect rect function. You pass the T-Rect of each T-Rectangle to the function, and it tells you if they intersected or not. Box2D is a third-party physics library that is also available with Delphi, but for simple collision detection like is in these games, intersect rec works well. On the main form of each game, I have a asset layout control, which is a T-layout, and I've showed you that a little bit already. A T-layout is an invisible control which you can use to manage your layouts. Inside the asset layout, I embedded the various game elements, like the enemies, projectiles, explosions, and power-ups using T-rectangles. This saves you from having to write all of the code to load those bitmaps at runtime. The asset layout control simply gets hidden at runtime, and you can access the bitmap elements as needed. Some elements of the games, like the player character and the game backgrounds, are not stored in the asset layout. Instead, they are set up at design time exactly how they will appear at runtime. The parent of the asset layout is the HUD layout control, which is also a T-layout. The HUD layout contains all of the control buttons and other display controls like the score, player health, player lives, etc. The parent of the HUD layout is the T-game form. The T-game form has a fill property, and the background image is set to the fill bitmap property with a wrap mode of tile stretch. By using tile stretch, the background will always automatically resize to whatever size device you're running the game on. On some of the other games, the background is handled differently. So here is the asset layout, which I told you about before. Here's, you can set it to hide, and that's what happens at runtime. At design time, it's visible, so you can see it. Here is the HUD layout, and you can see that which elements there are on the HUD layout. And then finally, the game form is here in the background, and you can see the background image is set up on its fill bitmap property, and then you can load and save different backgrounds there. So back to the asset layout, I already showed you the various elements, and it's got that dash dot around it, which you can change. I'll show that to you real quick. You can change that to solid, change it back to dash, and then you can also change the kind property to none, which is what happens at runtime, solid. And so these other elements are not in the asset layout. We can hide those so you can see the full screen there. In FireMonkey, animation can also be handled through the T-rectangle control. One example of this is the explosion animation. First, I created a T-rectangle, and then I dropped a T-bitmap list animation on it. The T-bitmap list animation component uses a sprite sheet bitmap for animation. A sprite sheet is all of the frames of an animation combined into a single image. The component then copies out each frame of the animation from coordinates on the sprite sheet one frame at a time to create the animation. In this case, the animation targets the fill bitmap property of the T-rectangle. The T-bitmap list animation has a lot of different properties, but I only used a few like animation count, animation row count, duration, and trigger. The trigger property watches for a property change, like if the isVisible property gets set to true, then the animation starts. I use the trigger property because the object pools. When the objects come out of the pool and get set to visible, it starts the animation. The game control buttons and other visible display graphics within the games are also built using T-rectangles and visually added directly to the main form at design time. The rest of the interface screens are built using frames. You could enhance the game to use a custom T-rectangle which might be implemented as a platform native object for increased drawing speed. So I'm just going to show you some of the T-bitmap list animation properties. So I'm selecting one of the enemies which has an animation on it. I'm going to scroll down and you'll see that here is the T-bitmap list animation, which is defined as a child of the enemy 3 parent here. And then you can see here is the animation bitmap, which is defined. And we're going to open that up. And there is the sprite sheet. You can load and save it there. Here is the animation count of 6 because there are 6 total frames. And then the row count of 2 because there was 2 rows of frames, and here is the duration set to 2. Here is the property that it's targeting, which is the fill bitmap, and finally the trigger property, which is set if isVisible equals true, then trigger the animation to start. Let's talk about the UI in frames. If you want to provide a professional game experience for your game, you need to provide all of the standard game menus which players are accustomed to. The different game menu screens were built using frames. Frames are similar to a form but behave more like a component that you visually design. You can create a frame, fill it with other components using the standard form editor, and then embed the frame multiple times in your forms. This allows you to quickly design, modularize, and reuse your UI. In these games, I created 6 frames, which include the main menu, the settings, the gamepad, the high scores, the instructions, the game over, and the level complete screens. So I'm going to show the various frames here. We've got the main menu frame, the settings frame, the gamepad, the high scores screen, the instruction screen, the game over screen, the various buttons and things, and the level complete screen with the text box here to add dynamic text at runtime. And so you'll notice that each of these frames does not have a theme applied to any of its graphical elements. And so if you go back to the main screen, I'll grab one of these frames. Let's find the main menu here, main menu frame, and I'm going to unhide it. And you will see that once it's embedded in the main form, the theme that you have set up using a style is applied to the frame. Generally, I use the align property to align each frame to content. The content setting ignores the other aligned controls and fills up the current parent control with the control being aligned, in this case the frame. For the UI elements like buttons that are on each frame, I use the anchors property to keep those elements positioned correctly regardless of the screen size. In FireMonkey, you can embed controls inside other controls, which allows you to create an exact interface that you want. In some cases, you will want to use a T-layout or a T-grid panel layout aligned to top or bottom to further segment your space and then embed other controls within them. Using this technique, you will be able to build a universal UI that looks great on TVs, desktops, tablets, and phone-sized devices. So I'm going to show you the align and the anchor properties. So here's one example. We're on the gamepad frame and we have a layout here. The layout is aligned to the top. On the left side we have the close button aligned to the left. On the right side we have the connect button aligned to the right. This fire button down here has align set to none, but its anchor properties are set to right and bottom so that if whatever screen size it ends up on, it will stick to the bottom right corner. And then over here on the game form, you can see that, so this is the main menu frame. I'm going to hide that, and then I'm going to find the gamepad frame and I'm to make that visible. And so you can see, even though the game area is different in size than the gamepad original frame, it has moved this property and anchored it down in the bottom right hand corner. And then we can hide, and the whole thing is set to align contents, and then it is visible false. All of the frames are embedded in the main form as set to visible equals false. A set stage function was created to manage the current state of the game and handle showing and hiding the different menus. Most of the frames don't have any extra code embedded in them, but the gamepad frame and the high scores frame both do. It made for easier organization to keep all of the gamepad code within the gamepad itself. The gamepad allows you to control the game from other devices via app tethering, which we will cover later. So here's the set stage function. Or procedure rather. You can see it uses a case to see what stage it's at. If it's the main menu, it performs these actions. If it's the instructions, these actions. And the gameplay, level complete, game over, high scores, settings, gamepad, etc. And then if I tap through some of these with the search function, you can see where show gamepad, it sets the stage to gamepad. Or show settings, it sets the stage to settings, etc. Main menu, game over, and all the various places where it needs to set the stage and bring up those frames to show that menu, it does so. You could enhance the game UI by moving the player control buttons into their own frame instead of using the HUD layout I showed you before, or you could even move all elements involving the gameplay into a new gameplay frame. This would make it even easier to create new games around the existing framework. Having the gameplay in its own frame would also allow you to load up different types of levels within the same game just by picking which frame to load into the current level. The second game we are going to talk about is called Mars Rocket. Mars Rocket is a classic arcade-style game where the player must collect points and land the rocket without crashing. On each level, 3 stars are randomly placed throughout the game screen, which you can collect for more points. Think of them along the lines of the mechanic in Angry Birds, where you can pass a level with only 1 star, but if you were really good, you can get all 3 stars. Along the bottom of the screen, a random number of platforms are generated in different sizes, which the player is able to land the rocket on. If the rocket is just slightly off, it will crash instead of landing. The player also has a limited amount of fuel in each level to land the rocket. The motion sensor controller really shines in this game as it makes controlling the rocket very intuitive. So I have Mars Rocket open in Delphi here. I'm going to show you the asset layout. I'm going to select the asset layout here. We've got an informational kind of a background screen that shows up on the level complete screen. Inside the asset layout we have the collectible stars, we have the platforms, and then we also have the player ship, which is not inside the asset layout. The asset layout is embedded in the HUD layout, which is here, and the HUD layout is embedded in the game form. And I also want to show you, so you can see all these various non-visual controls on the space, which can make it hard to visually design your game here. And so there's a way in these latest versions of Delphi to hide those controls. You can do Control H and hide those non-visual controls. And you can also, there's various buttons up here at the top. You can hide them with this button. And then through the view, you can, or edit here, hide visual, non-visual controls. So that's a good way to hide those and make it so you can easily design your game without those being in the way. So now I'm going to compile Mars Rocket in Delphi and show you how it plays. In a few seconds it's loaded up. I'm going to move it over here. I'm going to click play, continue, and then I'm going to use the rocket. I'm going to use the keyboard here to navigate around. I'm going to collect these 2 stars, and there's a platform here which has been randomly generated. I'm going to go land my rocket on the platform, and I successfully landed it. And then here's the second level, collected 3 stars. You can see that the platforms, there's different platforms, and I can also crash the rocket, and then you get another life. So that's pretty much Mars rocket. I'd like to share a screenshot of an early version of Mars rocket so you can see it in its skeleton form before the graphics were applied. You can see how T-rectangle is used. So here we have the rocket rectangle, we have the thruster button that gives you the velocity, and we have the left and right rotation buttons. We got these labels up here, and this is an original ground that I was using but ended up not being in the final game, and it was a randomly generated ground, but I used a different version of that in the final game. Let's talk about the motion sensor. The Team Motion Sensor component within the FireMonkey framework in Delphi gives you access to the accelerometer data on each platform. Usually you will have these sensors on your iOS and Android devices. When the motion sensor active property is set to true, the accelerometer data is accessed during the game loop in the process accelerometer function. For Mars rocket, the motion sensor is enabled by default, as the game plays best when you use the motion sensor. Tipping your device forward will fire your rocket engine, while tipping the device left and right will rotate the rocket in that direction. You can enable and disable the motion sensor using the gyroscope button at the top right of the game. You might enhance the game to include more control using the motion sensor, or to allow the devices acting as the gamepad to send motion control sensor data to the game. So I'd like to show you the process accelerometer function. I have it open here in the code window. It checks the motion sensor to see if it's nil. If it is, then exit. Otherwise, check the device orientation and collect the sensor data into the ACCY and ACCX, and then if it's a certain integer, then do one thing, otherwise do something else, and then it also does the left and right directions and the left and right directions again. So that's the process accelerometer. And if you go to the game loop, which I showed you before, you can see that it processes that information right here. So I've got Mars rocket open in Delphi here, and I'm going to demonstrate the motion sensor functionality. So what I've got is I have an iPad 2 here, and I have a Mac Mini off screen is connected via this USB cable, and Delphi connects to the PA server, and the PA server is running on the Mac Mini. Delphi deploys the IPA file over to the PA server. The PA server deploys the file to the iPad 2 here, and as you can see, I've got the 4 games on that, but I just want to demonstrate live. So I'm going to select the iOS device. It's connected to my iPad there via the PA server. I'm going to compile it, and it's going to take a few seconds here to deploy. And so once it deploys, I'm going to show you that I'm going to be able to move the device around like this. I'm going to be able to go like this and accelerate the rocket or turn left and right. And it's packing up all the files there now, and then it will send it over to the iPad 2 here. It's launching Mars rocket at the moment, and then I'll demonstrate the motion sensor here. Alright, so it's loaded up FireMonkey, and Mars rocket is now loaded up on this iPad 2 device, which is an iOS device, and then I'm going to do play, I'm going to do continue, and so I'm going to collect these stars here. As you can see, I'm rotating the device, I'm using the accelerometer by tipping forward. Alright, so I'm going to try to get the star here. And you can see at the back of the rocket there's a thruster graphic, and so each time I apply thrust by tipping the device forward, you can see that the thruster graphic turns on. I'm going to try to land my rocket here now on one of these platforms, try not to crash. I didn't make it. Alright, so over here you can see the velocity, the angle, fuel, the lives, the score. Over on this side is the debug label, and you can see that currently each game loop is taking 6 to 7 milliseconds. Up here at the top we have the gyroscope button, so if I get the ship up here in the middle here, and then I'll turn the gyroscope off. So now you can see that I'm no longer controlling the ship with the gyroscope, so I'll turn that back on and save the ship here. It's almost about to crash into the ground. And then there's also the sound and music buttons. You can turn those two things off. You'll also see that down here on that's the
thruster button and then the left and right buttons, there's a circle behind each of the buttons that turns on and kind of lights up the button. So you can see what button is being currently used by the accelerometer when you're using the accelerometer. All right, so now I'm going to go down and try to land the rocket on one of these platforms. Let's see if I can do it here. All right, come on. All right. Oh, that was close. All right, last life here to land the rocket and move on to the next screen. Or move on to the next level too. All right, come on. All right, so I successfully landed it here, and this is the, if you remember this over here, the asset layout, this screen gets used here on the level complete screen. And then the stars along the bottom here, that's a T-grid panel layout. So I'm going to move on to the next level and try to collect some more of these stars, and then, all right, this star is being difficult. All right, there's only a couple platforms here. This level's a little bit difficult. And you'll see my score up here. And also when the rocket goes above the screen, there's a little light that on the HUD that demonstrates where you are so that you don't lose the rocket if it flies above the screen. So each of the 4 games supports this functionality, but each of them does a little bit different because the controls are different. Oh, I didn't make it on that one. All right, so here's the high score screen. So that is Mars rocket deployed from Delphi to an iPad 2 and using the motion sensor.
Let's talk about the high scoring system. Most classic arcade games had a high scores system, and these games are no different. Everyone likes to leave their mark and then try to beat their previous score. The high score system within the game is implemented using FireDAC and SQLite. The code for handling the high score system is within the high scores frame. TFD connection is used via a FireDAC SQLite driver link to access the SQLite file. The contents of the high scores list is accessible via a FireDAC table component and connected via live bindings to a list view control. FireDAC query components are set up for inserting and deleting records from the high scores table. Only a few lines of code are needed to hook it all together, which includes things like creating the SQLite database file at runtime. You might enhance the high scores system to be pre-populated with high scores, or you might hook the high score system up to a server using the T-Rect client component so that players can compete against each other's high scores on a regional or global level. So I have the high scores frame in Mars Rocket opened here in the Delphi IDE, and I've got the list view selected. I'm just going to go through some of these components and show you the various components you need to set up the live binding and access SQLite. And so first we have TFD connection here, we have the TFD table, we have a TFD query for inserting and a TFD query for deleting, we have the bind components, we have a wait cursor, and we have the SQLite driver link. So I'm going to click over here on the list view, I'm going to scroll down to live bindings, and then I'm going to bring up bind visually, and you can see that here is the TFD table for the high scores, and it contains the name and the score, and those are linked to the item detail and the item text of the list view. And so then if I click over to the code, you can see all of the FireDAC includes here at the top. I'm going to close this out and I'll scroll down some more, and you'll see here's the cancel button. Here is after connecting, the TFD connection will create the high scores table if it does not exist. Before connecting, it will set up the path to the database, which is highscores.s3db. There is two other functions. There's the add score function, which calls save score, and save score inserts the score into the SQLite database. There's also a init frame function which gets called, and it sets up and connects to the database, and then a couple other functions here at the bottom. And then if we go over here to the main form, you can see that all of those non-visual controls are here in the main form as well. I can click on those, and then here's the high scores frame, and I can unhide that here, and so you can see that it's styled and embedded in the main frame of the game. So now I'm going to go ahead and play Mars Rocket and show you the high score screen in action. And loaded it up here. It took a couple seconds to compile. You play, continue, and I'm going to grab some of these stars, and if I can get back over here and land on one of these platforms, I'll move on to the next level. And so I've got 300 score now. I'm going to land, get some more score. So now I've got plenty of score. I'm going to collect these stars here, and if I get back over here, I'll be able to land my rocket. And landed, and then now I'm going to crash my rocket spectacularly. Oh, boom, into the mountain. And I'm going to go over here, crash, boom. And finally, if I get, oh, alright, so here's the high score screen. I can enter my name, Eli, okay, and then it's going to show up here in this list view down here at the bottom. I can continue, I can go to the main menu, and I can also view the high scores from here and see that there is my name. And so that's the high score system in action. The third game we're going to talk about is called Rocket Ship Delta. Rocket Ship Delta is probably the most complex of the 4 games, as it has the most number of objects moving around, and it even has a mini-map display. Rocket Ship Delta is a classic arcade side-scrolling game which gives you 4 directions of movement. In addition to a normal projectile weapon, the player also has access to a screen-clearing bomb and a warp functionality. The bomb is limited to 3 uses per game, but the warp has unlimited usage. The goal of the player is to stop the aliens from abducting the players on the planet's surface and carrying them off. Once an alien carries off a character, it upgrades itself and then comes back for more, better and stronger. On the left and right side of the game area, there is a wormhole which teleports the player to the other side of the game area. The background in this game is actually 3 different transparent layers which move based on the location of the player, creating a parallax effect. So I've got Rocket Ship Delta open in Delphi here, and I just want to go through the asset layout. Again, for this game, we have the various projectiles of the player that it phases through these different colors of the projectile. Here's the enemy projectile. Here's the bonus points. Here is the character that the enemies are capturing. Those are located at the bottom of the screen. Here is the bomb graphic, and that actually gets filled into these bomb rectangles over here. Here is the enemy rectangles of the 3 different enemy graphics, and there's a plasma wall that keeps you from going off the edges of the screen on the left and the right, and here is the wormhole graphic. The player graphic is here in the center, and then I just selected the HUD layout, which everything is contained within, and you can see it hidden there, and then finally everything is in the game form, and you will see in this game the background color is not set to a bitmap at all. It's just set to a color of black, and then the parallax is handled by these map layouts, and they contain various rectangles which move around to create the parallax effect. I'm going to open up those. Alright, so you can see that it's got all the stars and things in that one. In this one, it's got the stars again, and then finally in this one, you can see the stars in there. And then also, this map layout one, it contains the mountains rec down here at the bottom, and you can see that graphic here. And so that's the asset layout of Rocket Ship Delta. Alright, so now I'm going to compile Rocket Ship Delta here in Delphi and show you how it plays. Select it, move it over here, click play, continue through the instructions, fly my guy around. I'm going to use the keyboard here. There's an enemy. Use the wormhole. Alright, that enemy just upgraded. I got that guy. And then I'm going to show you the bomb. The bomb destroys the different, and I'm going to collect this, missed the power up. I'm going to shoot that guy. I'm flying around over here. I'm going to use the warp here. So you can see, and now there's a bunch of enemies. I'm going to use the bomb, destroy all those guys, and I'm going to fly around here. You can see the parallax in the background, the 3 different layers moving. Collected that bonus power up. That guy's chasing me. One more enemy over here, and then level complete. I'd like to share a screenshot of an early version of Rocket Ship Delta so you can see it in its skeleton form before the graphics were applied. You can see how T-rectangle is used. So we've got the enemy rectangles here. We have the player rectangle. We have some projectiles from the enemies and the players. And then we have the fire button. We have the left and the right buttons and the up and down button. You can see that the bomb button and the warp button were not in the prototype at that time. Let's talk about object pooling. Creating and destroying objects on mobile can be expensive performance-wise. The T-string list component was used to implement a simple object pooling system. When the game is initialized, all of the object lists are created. If a new object like an enemy, explosion, or projectile is needed, it is created and added to a list. Once it is no longer needed, it goes back into the list for reuse later. Looking objects up by string is currently not used, but is available for future use if you were going to add special types of enemy characters, for example. At the end of each game, the lists clean up all the objects and are then removed. The T-string list has a property called owns objects, which will automatically clean up all of the objects attached to its list. You might refactor the game to use T-dictionary or to prime the object pools for better performance in later levels when there are more objects. So I have the Rocket Ship Delta code open here in Delphi, and I just want to show you the object pooling functions that I set up. There's get pool object and there's set pool object. Now get pool object, if there is an object in the pool, it will return it, and if there is not, it will create it. And so in this case, it's a T rectangle and returns that. And then set pool objects is when you're done with an object, you can set it back into the pool using set pool objects. And so here's an example of it being used in spawn projectile. It gets the object and uses it, and then it returns it at the end of that function. And if we go over to the game loop and we find the set pool function, we've got the explosion list here. Once this explosion is complete, it will set the explosion object back into the explosion pool and remove it from the list. And then finally, if we go over to init game, you will see where we create all of the object pool objects here, which are T-string lists. We create them all there. And then if we go to cleanup game, you will see how we set owns objects on all of the objects, auto pools and things that are there. And then we free and nil them at the end to remove all the objects from the game. Let's talk about animation. We covered the animation a bit already, but animation is implemented using the T-bitmaplist animation component, which is built into the FireMonkey framework. T-bitmaplist animation uses a sprite sheet, which features each frame of an animation on a single bitmap. The frames are copied from the sprite sheet and drawn in place to create the animation. Creating a sprite sheet to use in Delphi can be tricky because a lot of the art tools out there export a sprite sheet in a different size than what Delphi is expecting. Delphi expects a sprite sheet that is the exact width and height of the number of frames in your animation. If you have 6 frames, which are each 50 pixels wide and 50 pixels high, and they are laid out on the sprite sheet in a 3x2 grid, your sprite sheet would be 150 pixels wide and 100 pixels high. You may have to trim down your exported sprite sheet before loading into Delphi if it is not in that format. There was one version of iOS which caused problems with the animations if they attempted to run while the game was being transitioned to the background. I created a new function called pause bitmap list animations, which loops through and pauses all the animations before the game is backgrounded. When the game enters the foreground again, the animations are all restarted. A side effect of this is that the games may now take less resources when in the background on some mobile devices. I have the Adobe Flash animation tool here, and I have an explosion graphic opened up in it, and you can see the different frames of the explosion. And then I have it created over here as a single object, and if I right click on it and I generate sprite sheet, you will see that here is the grid that you can export as a sprite sheet from this program. Lots of different programs support exporting sprite sheets. I just use this one because it's easy and simple for me. Here's the preview of the explosion in action, and so you can see here is 3 across and then 3 across and this last one. So there's 1, 2, 3, 4, 5, 6, 7. There's 7 frames here, and then the last 2 frames will be blank, 8 and 9. And so you can also see that the width and height of this one is going to be 256 by 256. But the sprite sheet you would want in Delphi, you would want the size to be 150 by 150. And so after you export this sprite sheet, you can trim off this extra space on the image that you won't need. And so that's how you export. You just export the sprite sheet and you can trim it up and then load it up into Delphi. The final game we are going to talk about is called Space Rocks. Space Rocks is a classic arcade-style game where the player starts at the center of the screen surrounded by a number of asteroids. The player can rotate their spaceship left and right as well as accelerate forward. The player has an inertia from each acceleration which slows down over time. The goal of the game is to destroy the asteroids so you can move on to the next level. Each time you shoot one of the asteroids, it breaks up into smaller pieces. Additionally, there are alien spaceships which crisscross the screen and randomly shoot projectiles at the player to keep you on your toes. I have the Space Rocks game open in Delphi here, and I just want to show you the asset layout like I've showed you for the other games. Here's the asset layout. Here's the different Space Rocks objects. We've got the random enemy ship that flies back and forth. We have the player projectile. We have the enemy projectile. We have the bonus object. We have the player health object. And as you can see, the asset layout is on the HUD layout, and I can hide the HUD layout to show you that. And then finally, everything is on the game form. And so if I go over to the background fill for this game, you can see that it is a bitmap like the Alien Invasion game, and so there is that background, and it is set to tile stretch, and that's the asset layout for Space Rocks. I'd also like to cover some of these other non-visual controls. So for example, here we've got the delayed settings timer. That sets some settings on the load of the game out on timer, and then we have TID TCP client, which is involved with app tethering. We have the motion sensor control here. We have the music player here. We have the style book, which contains a style that themes the game. We have the controls from the high score system. So that's the SQL Lite driver. And we have the game loop timer here. We have an invulnerability timer here. So the invulnerability timer, when your character is destroyed and it comes back, you have about a few seconds, looks like maybe 3 seconds, where you won't be able to be hit by the enemies. And so that gives a little bit of time to come back into the game without being destroyed over and over and over again. And so these other controls are just the high score control. These are involved with app tethering, which we'll talk about in a minute. And those are the various, and so up here we have the debug label that I talked about originally as well. So now we're going to compile Space Rocks here in Delphi and show you how it plays. I'm going to move it over here to the center. I'm going to scale it up a little bit so you can see how it scales to any screen size. I'm going to go into play, continue. I'm going to use the keyboard here to play. I'm going to destroy some of these rocks. There comes the random enemies. You'll notice that the player projectiles in this game, they wrap around to the other side of the screen. I can accelerate my player. I can accelerate the other direction. You'll see that I got some inertia there. You can see when the thruster is active, that's that graphic at the back of the rocket, that I'm pressing the accelerate key, and then when it's not, I'm not pressing the key, but I still have some inertia going on. You can see that I can turn left and right using the mouse. I can fire using the mouse, and I can move forward using the mouse as well. And then these are the music and the sound buttons. That's actually the music button, and this is the sound button. And there's a power up, and that's the play of Space Rocks. I'd like to share a screenshot of an early version of Space Rocks so you can see it in its skeleton form before the graphics were applied. You can see how T-rectangle is used. So in this version you can see that the player's character is already applied to a T-rectangle, but here's the player's projectiles. Here are the Space Rocks floating around. Here is the fire projectile button and the rotate and left and right buttons. Let's talk about app tethering. App tethering is a group of components that comes with Delphi for easily communicating between your Delphi apps on different devices. You can connect via Bluetooth or over an IP network connection. Packets in the IP network connection are sent via the UDP protocol for connecting and discovery. TCP is used for communicating after the connection is made. The components in the games are set up to use the IP connection. App tethering is actually peer-to-peer, but in this implementation it acts as a client and server. Keep in mind that network congestion and your Wi-Fi signal quality will affect app tethering. The app tethering implementation within the 4 games allows you to run one device as a game controller or gamepad and a second device where the game is running. For example, you can have your Android phone set up as the gamepad controlling a game on your iPad, or you can have your iPad device be the gamepad controlling the game running on a Mac OS X device connected to a big screen TV. You can even have your Windows machine be the gamepad and play the game on your iPad Pro using the keyboard from the Windows machine. The server side of the app tethering components are embedded in the main form, and the client side of the app tethering components are embedded in the gamepad frame. The game itself has actions set up for each of the control functions within the game. On the gamepad side, each button is set up to run one of the remote actions asynchronously. Press a button in the gamepad, the action is sent via app tethering, and the action gets executed in the game. Keep in mind that because the actions are sent asynchronously, you will need to thread synchronize any code within the actions that modifies the UI. You might enhance the game to include more robust app tethering support for connecting between devices or to use Bluetooth instead of IP networking. The current UI for app tethering in the games is functional, but could be expanded to better handle connection errors. So I've got Space Rocks open in Delphi here, and I just want to run through the various app tethering components. So we've got the tethering manager and the tethering app profile, and these are, I'm going to call them the server components in this instance, and they use the action list. Here's the action list editor. There's the various actions that can be executed from the gamepad. We go over to the gamepad. You can see here's the buttons on the gamepad. We've got connect, close, things like that. We have the tethering manager that the gamepad uses to connect to the server side client when you're playing the game, and we've got the tethering app profile. If we look at the code, when you push the various gamepad buttons, it runs through button action, sends an ID, and then it uses run remote action async to asynchronously execute the actions in the game from the gamepad here. And so then if we switch back to the game and we go to the code here, you can see that it runs, when you push one of those buttons, the up action, in this instance, up action down execute gets executed, and it gets called from run remote action async. And so if you do any kind of UI changes here, you need to thread synchronize. So in the fire action down execute action, we do thread synchronize because when you're playing the game, if your character gets destroyed or whatever and you have to move through the game screens, the game over screen, the high score screen, you can navigate through the game using the fire button to move through the various menu items, in addition to using the fire button to fire the projectiles while you're in the game.
Space Rocks open in Delphi here. What I'm going to do now is I'm going to demonstrate the app tethering and the gamepad functionality. So I've got my Nexus 7 Android device here, and I'm going to select the Android target over in the Delphi IDE, and then I'm going to deploy Space Rocks to the Android device. And once it gets loaded up on the Android device, I'm going to load up the gamepad, and then I'm also going to compile it for Windows 32, and then the Android device is going to connect to the Windows 32 version, and we're going to play the game via app tethering from the Android device. And so you can use different devices. You can use an Apple device, you can use an Android phone. Any of those different devices can use the app tethering to play the games across to different platforms. We're going to demonstrate this, load it up FireMonkey now, and so we've got Space Rocks running on the Android device. I'm going to go over here to the Windows 32 target. I'm going to deploy it to that target, and then I'm going to go to settings. I'm going to set it to full screen. I'm going to turn on the app tethering gamepad server. I'm going to go to the main menu. I'm going to go to play, and then I'm going to go to the gamepad over here, and I'm going to connect to the Windows machine. It's connected. I'm going to enter the game here, and you can see I'm playing the game with the Android device as the gamepad on the Windows machine. The Windows machine's in full screen here. I can fly around. The Space Rocks flying around on the Windows machine using the Android device as the controller. Oh, I just got hit. So the goal of this game is to clear out all the rocks, Space Rocks, and so I'm going to try to do that here. Show you guys just some gameplay while I play. And so you can see that there's a bonus. I'm going to try to get that bonus. Missed it. Alright, so and you can see those pink spaceships flying around. those are the random enemies that are defined within the game. If I can just destroy all these rocks here, we'll move on to the next level screen. I'm getting close, I think. There's another enemy. And in Space Rocks, the projectiles of the player actually wrap around the screen, and you can actually fly off the screen too. You can fly off the edge and do this, and then you appear on the other side of the screen. So that functionality is defined within the code of the game. I'm getting close here. I think I've got a few. If I can just get this Space Rock here, got that one. Some down here I'm going to try to get. Alright, there must be there's one more Space Rock up here in the corner. Alright. I'm going to finalize this level here. Got that last Space Rock, and there's a couple enemies left. Random enemy spaceships, and destroy that guy. And there you go, level complete.
Let's talk about cross-platform sound. The FireMonkey framework comes with the T-Media Player component for playing audio and video files. The T-Media Player component is not really designed to play the quick sound effects you need in a game, but it works great for a music track. We used the T-Media Player component for the music and had to manually implement music looping as it is not built into the component. Additionally, when stopping and starting the music, we simply adjust the volume because of the performance hit that happens when stopping and starting an audio file. We put together a cross-platform component called T-Audio Manager, where small sound files can be registered and played with ease. The T-Audio Manager component uses platform-native APIs and ifdefs to play the sound files from a single source code on Android, iOS, Windows, and Mac OS X. On iOS, it imports 4 functions from the Apple Audio Toolbox framework. You must add this framework to your iOS SDK in the IDE before you will be able to compile the project to iOS. On the Android side, Audio Manager and Sound Pool from the Android SDK are used. On Mac OS X, an NS Sound object is used. And finally on Windows, the SND Play Sound API call is used. Deploying sound files to each individual platform is slightly different. On iOS, you must deploy the files to the Startup Documents directory. On Android, you must deploy the files to the Assets internal directory. On Mac OS X, the directory is automatically configured to deploy to the Contents Resources Startup directory. Finally, for Windows, you need to manually copy the sound files, both star.wav and star.mp3 files, to the same directory as the executable. There is an ifdef within the formCreate event, which defines where the sound files get loaded from. For Windows, you can use the path in the classic param_str0 function. For Mac OS X, the system IOUtils tpath get home path function corresponds with the deployment directory. And for Android and iOS, the system IOUtils tpath get documents path function corresponds with the deployment directory. You might enhance the game to include even more sound effects and even apply sound effects to the various buttons throughout the UI when they are selected. You could even implement a voice recognition control system for navigating the menus or some of the in-game functions. So here I have the formCreate event in Space Rocks here in Delphi, and you can see here at the top where it sets the path that depending on the operating system for the data file path, and that's what it uses to load the sound files. If we scroll down a little bit more, you can see it creates the audio manager, and then it registers these various sound files with the sound system. And then if we go up to deployment, you can see that the Windows path here is set, the remote path, but on the various other platforms, and if we sort these, you'll see that here's the fire.wav file, and it is set to Assets Internal as the remote path, and then if we go over to iOS, you can see the fire.wav file, and it is set to the Startup Documents remote path. And then if we switch over to OS X, it has its Content Resources Startup directory set up there. We can also look through the Audio Manager code a little bit. So here at the top we have our ifdefs for Android, iOS, Mac OS, and Windows. And so we scroll through some various other ifdefs. We have the T-Audio Manager class some more if-defs for Android, various functions here. We have the framework import for the audio toolbox for iOS and the 4 different functions that it uses for playing the sounds on iOS. We have the callback, which is used on Android, and then we have the create. It creates the audio manager, the sound pool. We destroy, clean everything up there, and we can add a sound to the audio manager, and it's got the various if-defs here, and you can delete a sound with various if-defs, and then finally you can play a sound. So it's got these if-defs for Android, iOS, and then on Android it goes through and it does a sound pool play. On iOS it does a audio services play system sound using the sound that was registered, and on Mac OS X it uses a TNS sound, and then on Windows finally it does SND play sound, the file name. And that is the Audio Manager class. Sound and music. There are a number of different sound effects generators online you can use to generate the in-game sound effects. SFXer lets you generate pick-up sounds, coin sounds, laser sounds, explosion sounds, power-up sounds, hit sounds, hurt sounds, jump sounds, blip, and select sounds. There are a number of different variations now that are derived from SFXer. One is called Chiptunes and the other is called BFXer. Both of these are more advanced versions with more features, but the sounds generated are also slightly different than the original. For music, you can search on your favorite search engine for Flash Music Maker, and there are all kinds of different sound creation tools that you can use in your browser. Computozer has computer-generated songs in various genres that you can use under a Creative Commons license. Shockwave Sound is a royalty-free sound license service where you can generally license songs for around $30. Lastly, Omada is just one example of the many Flash music makers out there. Omada claims to have no restrictions on music generated using the tool. Generally, the various Flash music makers lets you add samples onto a looping track which creates a beat. Be sure to check the license for the music generated in each different tool before using. So here's the SFXer tool, and as you can see it's got the various sounds you can generate over here, so I'm going to click some of them. And it just kind of gives you a random version of that type of sound. And then if we switch over to BFXer, it's kind of the same kind of thing. It just has lots and lots more options. And then you can easily export and save the sounds over here. And then I'm going to switch over to Omada, and then I'm going to play this. And you can see that it comes up with a tune that you can record and export and use in your game. The game's compiled to 4 different platforms from a single codebase in Delphi. All 4 platforms can also talk to each other and control the games across devices on Android, iOS, Windows, and OS X.
So I've got Rocket Ship Delta open in Delphi here, and I'm just going to deploy to each of the 4 platforms that it supports. Actually more because Windows 64-bit, but we're going to start with Android here. I'm just going to select my Android Nexus 7 device and bring that up in so you can see that. And then I'm going to just start deploying to this device. And then after that one, I'm going to show you the iOS device. I'm going to show you an Android phone. I'm going to show you a Mac OS device, and I'm going to also compile to Win32 and Win64. And so once the Rocket Ship Delta deploys over here to the Nexus 7, I'm going to turn on the motion sensor and then show you the control on the Android device using the motion sensor in Rocket Ship Delta. So it's installing the APK now over to the Android device. So it's connected via the USB cable directly into my computer and connected to Delphi. So there's FireMonkey launching. I'm going to hit play here, continue, and then so I've already got the gyroscope on. So I'm moving around with the gyroscope. And personally on the mobile devices, I think the gyroscope or the accelerometer provides the best control. Looks like I need a bomb. This guy's a little too many guys running around trying to get me. crash into that guy. Another bomb. Alright, so moving around with the gyroscope, you can see the parallax in the background. You can see the mini-map at the top. Let's scroll up here at the top of the screen. Collected a bonus. Go through this wormhole, crash. Alright, so there's a level in on Android Nexus device. So I'm going to put that down, and then I'm going to select the next device. I'm going to deploy it to a Samsung S6 Galaxy device. So bring that up into view. Start deploying to that device. And so with this device, I'm just going to play on the screen with the on-screen buttons instead of using the gyroscope. So it's packaging up the APK now. And all the icons and the splash screen and things, those are all put into the APK file, and you can configure those for Android as well. And I'm also going to show you that you can rotate the device, and you'll see a portrait mode and a landscape mode, and the device or the FireMonkey app automatically handles that and resizes itself as needed. Alright, so I'm going to go in and play here. So I'm going to accelerate here with my left and right keys. That guy, I'm going to use a bomb on that guy. He was moving pretty quick. He was capturing that person. That guy's following me. Going through a wormhole here. So I need to go back here and bomb these guys. Alright, so I'm just turning around. That guy he just captured a character. I'm stuck on the plasma wall. I just use the warp gate. And so this is Android phone size device. And as you can see, it automatically figured out the screen size and made the game playable on this size device versus the Nexus 7 tablet. And that's all handled with the align and anchor tags. All right, so that was that level. So then I'm going to exit out of there, and then I'm going to bring up the next device, which is the iPad 2. I'm going to switch over to the iOS device. So bring up the iPad 2 into view. So we've got this USB cable is connected to my Mac Mini. The Mac Mini has PA server running on it, and Delphi is connected over my network to the PA server. I'm going to start deploying to the iPad. So right now it's packaging up all of the resources, the splash screens, the icons, and you can configure those. They don't have to be the same FireMonkey ones. You can make all your own custom icons and things like that. So this is one code base, all these different devices, and one UI for all of them without having a custom display for each different screen size or anything like that. It's just one for all. Alright, so here's FireMonkey loading up. I'm going to do play. I'm going to turn on the gyroscope on this one. So we've got Rocket Ship Delta here running on an iPad 2. Same code base, same UI that I just ran on an Android phone. Compiled across platform to all of them. Flying around, destroying all these guys. Uh-oh, that guy's about to capture. I got that guy using my bomb. I need another bomb there. I'm going to go through this warp gate and see if I can clear out all these guys. Oh, finish the level. So there was Rocket Ship Delta. Let's see if I can get to a high score screen. It'll show that. I can clear all of these guys. Maybe if I move on to the next level and get this high score screen to come up. I think I have 1 life left and about 3 health left. I'm just going to fly around here for a minute. Use a bomb on those guys. They've got... Uh-oh, that guy's going in for a capture. Let's see if I can go up and save this guy. Nope, too late. Alright, so I've got 1 health left. And so just so I can just demonstrate the high score screen. Alright, so here's the high score screen. I'm going to enter my name. I'm going to rotate it this way. Get rid of the keyboard. Back. Do OK. And so there's my name up there, the high score. And that's all using FireDAC, the high score system. Alright, so that was Rocket Ship Delta on an iPad 2. And now we're going to deploy it to Win32. So I'm going to select that over here in the IDE. And I'll make the screen a little bit bigger. So this game, Rocket Ship Delta, it's actually created mainly for mobile devices. If you make the screen a little bit too big, you'll start seeing both plasma walls on either end of the screen because it's built for mobile devices. But I mean, it runs good as long as you don't make it too big on a large desktop machine. Alright, so I'm clearing all these guys out. You can see the parallax there in the background. That's the 3 different layers there that gives you the illusion of depth. You've got the mini-map at the top. The yellow guys are the guys you're trying to keep from being captured. The blue guys are the enemies, and your character is the white dot on the mini-map. So the Rocket Ship Delta is the only game of the 4 that has a mini-map. So this is, so I'm mainly using the keyboard here to control this. I can go over and use the mouse though. Alright, so I'm using the mouse, and then I can also, so I can use the keyboard to fly around, and then I can use the mouse to fire. Well, it feels like a pretty good control interface. Alright, so that guy's going to go for a capture. Alright, got rid of that guy. So level complete on Windows 32. Now I'm going to switch to Windows 64-bit. I'm going to run that. It's going to compile up here in Delphi. I'm going to make the screen a little bit bigger here now, and then move it over here. Play, continue, and I use the mouse this time. Maybe. So it's got some inertia going on. And if I use the mouse, kind of difficult to use just the mouse to play this game. Alright, got that guy. I'm going to use the keyboard and the mouse again. Maybe I'll just use the keyboard and bring it up into the view. Alright, so we've got the keyboard, and I'm using just the keyboard now on Windows 64-bit. Destroy all these guys. Looks like I need a bomb. Alright, cleared all those guys out. So in this game, it's got the bomb, which is pretty powerful, but you kind of need it because there's so many different enemies flying around. And then you also got the warp, which you can use to escape trouble if you're really good. Looks like there's one enemy left, and he's going in for a capture over here on the mini-map. I'm going to go capture him. Alright, level complete on that. So I'm going to continue, and then I'm going to exit out of that game. And then finally, I'm going to move over to Mac OS X, and I'm going to deploy over to that device. So now I've deployed it to Mac OS X. Alright, so here we've got Rocket Ship Delta deployed over to the Mac Mini, which is Mac OS X 10. And so I'm going to fly around through the wormhole here and destroy some enemy spawn and destroy him and try to get this power up. And so you can see the parallax in the background there. That's the 3 different layers that it creates an illusion of depth. Try to get that bonus. Use the bomb on those guys. Bomb's pretty useful. And I also like the free warp. That's a pretty fun mechanic to have. Destroy those guys. So this is a big screen TV here that the Mac Mini is connected to, and I'm using the keyboard and the mouse. Alright, use the bomb on those guys. I saved that one guy. Here's the guy falling back to the planet. There's the plasma fence keeping me from going to the other areas. And that is Rocket Ship Delta deployed to a Mac Mini with a big screen TV display. So I'd also like to show Rocket Ship Delta connecting from an iPad device to an Android device using app tethering. So we'll use a gamepad on the Android device and we'll connect to the game on Rocket Ship Delta. So I'm going to go into the settings in Rocket Ship Delta. If I only had 4 hands here, this would be much easier. I'm going to go to turn on app tethering there, go back to the main menu, and then over here in Rocket Ship Delta on Android, I'm going to go into the gamepad and I'm going to connect here to the iOS device. App tethering is now connected, and I'm going to set this down here real quick. And then I've got the gamepad open here, I'm connected, and I'm going to start playing here using the Android device. Alright, so now I'm flying around and firing the Android device on the iPad. So we've got cross-platform app tethering happening right now. I'm going to use the bomb here, a bunch of guys, use the warp, and scroll down and get some of these guys. The cross-platform app tethering between Android and iOS device. And this also works between Windows and Mac and iOS and Android all together. So all 4 platforms can all talk to each other using the same app tethering protocol. which connects via UDP and then transports via TCP. So that is, get those guys. All right, I got destroyed. All right, so you can also see that the fire button there is also the continue button. So if you do get destroyed, you can just stick with the gamepad. You don't have to switch back over to the mouse or go over here and touch this to move on to the next level or to restart the level. All right, there's the bomb, and go over here and hit this warp. All right, so that is cross-platform app tethering. So now I want to demonstrate connecting two different devices as gamepads to the same game. So both different devices can both simultaneously control the game. It's not two-player, but both different devices can both connect and control the game. So I'm going to set up the game here. The gamepad is turned on. I've got an Android phone here. You can see if I can rotate it, it does the phone portrait view and landscape view. So go back to this view, and then I'm getting the gamepad. I'm going to connect to the Rocket Ship Delta game, and so then I'm going to hit continue. All right, so that one's connected. I'm going to go over here to this version. I've got Rocket Ship Delta here on the Android Nexus 7 tablet. I'm going to connect via app tethering using this tablet. All right, it's connected, and so then I've got two devices here, and as you can see, I'm moving to the left with the Android phone, and I'm firing with the Android tablet. Use the bomb, and use the warp here. Use the warp, use the bomb again. All right, firing. I'm gonna move up here. All right, so there you have two different devices, both connected via app tethering and controlling the same game. So for example, two different people could play and then swap turns without having to swap a device, or you could add your own multiplayer in here pretty easily. So there's a level complete screen. And all the games support doing this using the app tethering. So I also want to demonstrate connecting from Windows using the Windows keyboard as the gamepad to an iPad device and controlling the iPad from the Windows keyboard. So I've got the Rocket Ship Delta set up over here as the app tethering server, and I've got Delphi open here, and I'm going to compile it to Windows 64 because why not? It handles all these platforms over here. I'm going to go to the gamepad, and I'm going to connect the app tethering to the iPad 2 device, and now it's connected. I'm going to go down here to the keyboard, and I'm going to click fire to move into the game. And so now I'm moving around using the keyboard. Use the bomb key. I'm using the Windows keyboard here to control the iPad. There. Now I can use the space bar and the arrow keys all at the same time. So Windows keyboard, controlling the iPad. Use the bomb key here. Got those guys. They got toasted. All right, just there you have it. The Windows keyboard connected via app tethering to an iPad machine and controlling it.
For more game dev resources, you can visit emmanuelferranato.com, where there are over 3,000 game dev tips, tricks, and prototypes. There are over 150 popular game mechanics explained on the site, everything from Angry Birds to Tetris. You can easily translate the prototypes and concepts from JavaScript, HTML5, and Flash to Delphi and quickly deploy your games to Android, iOS, OS X, and Windows. Quite a few developers around the world worked on these 4 games, so I'd just like to say thank you to everyone. In case you missed it, you can access the source code at embt.co/Delphi Games 2016. That's about it for now. Thank you.
Okay, this is David I, and Eli M is online with us. Eli.
Hey.
Hey, sounds great. So first, I think and foremost, I think you mentioned this along the way, if they go to the URL and they go to the GitHub, they'll see, what, 3 different folders on the GitHub for different versions of the game?
In the one link, there's 2 different folders. There is one folder for full versions, so if you have Pro or Pro with Mobile or any of the higher versions of that of Delphi, you should probably use that version. It uses FireDAC. It also has the app tethering built into it. And then the second folder is the starter folder. That folder has the same game basically, but the app tethering part has been removed, and FireDAC has also been removed. And TMEM-INI file is used for the high score system instead of SQLite and FireDAC for that. And there's also on GitHub, you should be able to find, maybe I'll add it to this post too, there's also C++ versions of the games as well if you'd rather use C++.
Okay, and then there was questions about how you handle or how the games behave on different resolutions on different devices.
All right, so it kind of depends on the device. These games were built to kind of, they auto-size to the screen, and by doing that, they create more real estate, so the game kind of changes depending on what device you're on. So, for example, in the Alien Invasion, you'll see if you do a full screen on Windows, which on a 1080p monitor or something, you'll see that there's much more screen real estate. The projectiles take longer to get to the top of the screen or longer to get to the enemies, versus if you run it on a phone where it's kind of designed for the phone size screen, and so it just depends on which screen size you're running. Now, there is ways where you can make it so it stretches and you get the same game experience on all screen sizes, and you can probably use the, I forget the name of the control, but there's a stretch layout that you can use, I believe, that would allow you to do that. These games don't do that, though. They fit to all screen sizes, but at the same time, the screen real estate kind of changes a little bit.
And then for the main form, this is my own question. Do you turn on the full screen property for the form, or on Windows will it minimize, maximize, and other things?
So it offers both. In the settings, you can turn on full screen. It just changes that setting. And so on the Android devices, and I'm not sure about iOS, but on some of the mobile devices, when you set the full screen, it gets rid of the top bar that has like the time and the Wi-Fi stuff at the top of that when you do the full screen. And then on Windows, yes, it supports going full screen, and you can switch back and forth between those modes.
Okay. There was a question about what tool you use to create all the different graphic elements.
All right, so Adobe Flash was mainly used to create the graphic elements and also the animations to some extent.
I think someone was mentioning they downloaded the samples and they were getting some errors, and do you just suggest to do a clean and rebuild or close and open the project again?
Well, if you're having errors and you're using the starter, make sure that you're using the starter versions. There is an issue. The IDE can go weird with T-Grid panel. The T-Grid panel, that's not quite the name of the component.
T-Grid layout, maybe? T-Grid layout?
Right, T-Grid layout panel, I believe. So that one can go weird. So I think that really only happens in Mars Rocket. So if that does happen, you should probably just restart the project. And if somehow it still doesn't fix, maybe just unzip the project again, and it should load up and be fine. If you're having FireDAC issues, I think somebody was having that, but I think they corrected them by just switching to the starter version. So I'm not sure if you have Pro and Mobile and not the FireDAC client pack, though I think I've used that, and that should work too, whether the FileDAC will work there. But if you run any of those issues, the starter version should probably work fine for you. It just uses the INI file instead of FireDAC.
Somebody was asking about using a joystick, and it looks like you put a link to a joystick interface for Delphi. Is that it?
Right. There's a couple different, Winsoft.sk has a couple different joystick components. One of them is a DirectX joystick component with more options, and the second one is, I think it's just a general joystick component that I'm reading about. Joystick position and status, that's basically what it has. And then they also have a COM port, like if you have some other kind of device that uses a serial port that you want to use, they also have COM port components that will allow you to connect to those devices. And Delphi has built-in Bluetooth and Bluetooth LE components if you have some kind of Bluetooth controller that you wanted to use with it.
Yeah, there was a question that was off topic to game development, but about using the camera, and I pointed to a sample. There's a camera component sample in the mobile snippets, and that runs on Win32, Win64, and all the different devices, as long as you have a camera. I've even tested it on my Samsung Slate, which is an Intel tablet notebook kind of thing, and it has 2 cameras. And there's when you have the T camera component, there's a property called kind, and you can set the camera kind to default, and then it's whatever the default camera is, or you can choose the front camera or back camera if your device has 2 cameras, like your Windows device, or most smartphones and tablets now seem to have a forward and backward facing camera as well. So the default camera is whatever the hardware and the driver says the default is, but you can choose front or back camera as well if you're doing camera work. Some questions again, and Eli alluded to this, about what about database development in Starter? And database development is not included in Starter, but there's a special promotion right now to upgrade from Starter to Professional, including the free mobile pack. So check out shop.embarcadero.com. You can upgrade from your free Starter to the Pro and get the mobile pack at the same time. And Pro has database support with FireDAC, so for local databases, so for SQLite, Interbase Lite, and other SQL databases running on local host, you can do that with Pro Edition. If you want to talk to remote databases or multi-tier, then you need the Enterprise and Above or the FireDAC client server add-on pack. Somebody asked about Google Maps. There's a couple ways. On smartphones, there's the T-Map view, but there also is a sample I linked to the location sample in the Object Pascal mobile snippets. Uses the T-Web browser and calls into the Google Maps URL interface, passing the latitude and longitude as parameters. So there was a question about 3D game development. Do you have any advice? Somebody was mentioning Unity. I think Unity costs $1,500 per developer per platform, whereas with FireMonkey and even Starter Edition, you get 2D and 3D and free deployment. Any other thoughts about 3D? I mean, there's more with sprites and collisions and other things in 3D space as well.
There's lots of tools to do 3D game development, and I mean, but with Delphi you can also go directly to OpenGL if you want. So like if you just want to go directly to the metal and do OpenGL development, you can totally do that with Delphi. If you want WYSIWYG, all kinds of libraries and stuff, yes, there's lots of different tools out there to do 3D development. I mean, Delphi can do that too. Like for example, I prototyped a FireMonkey Go version of like Pokemon Go, and it was easily doable to do that kind of 3D within Delphi because it's not like a full-on 3D game where you're running through whatever. It's kind of a mashup of maps and camera and 3D and alternate reality and all that stuff into a single game, and so that was easily doable with Delphi.
And then we had, I put in the notes, and there's in the DocWiki as well, for 2D on Windows, FireMonkey uses DirectX, Direct 2D, and then 3D, Direct 3D on Windows. For 2D, I think it's Cocoa on macOS and iOS for 2D, and OpenGL on macOS for 3D. For iOS, and Android 3D, it's OpenGLES. And then for Android 2D, it's just native Android 2D interfaces for doing things. But again, as you mentioned, all of these games, even if using Starter Edition, you can compile and run on Win32. The other version, and we'll cover mobile tomorrow on day 5, I've tried and used all these games on all the platforms. And the sound works and the play works just as you saw in the demo. So you have great ability. Eli, it's not a question, but it came up the other day. For physics engines, we have Box2D interface built in. I know some people use Newton Dynamics, I believe, and maybe there was another one called Sphinx. I don't know if it's still around. There's some 3D game engines, physics engines out there.
Right. I did it before Box2D was included with Delphi. I did a conversion of Box2D to allow it to run on Android through Delphi, and so that was pretty fun. I created some games with that. Personally, I don't use Box2D a lot. I find it kind of complex. I like more just go change some code and it works. Box2D is more involved, so that's just my personal preference. As far as the other engines, I haven't really used any other engines. Like even with other game development tools that I've used, mainly it was Box2D. I didn't use any of the others that you mentioned.
Okay. Yeah, I played with Newton Dynamics 3D physics engine for a while. They had a Delphi interface unit, and then it had some samples for having like dominoes that, click and knock each other over, and Rube Goldberg type machines. So people can check out Newton Dynamics. Newton, like the physicist, right? Famous Newton guy. Let's see, for audio formats, there's lots of different formats. It also can depend on which audio codecs you have installed. I put the link to the T-Media Codec Manager DocWiki page, as well as links to other DocWiki pages in the Q&A. There's sort of the standard ones that you would expect on Windows, MP3, WAV, WMA for audio, for OS X, M4A, CAF, those are Mac OS ones, the same on iOS, and then Android MP3 and .caf. If you have Pro and above, you can go and look at the interface units for T-Codec Manager, where in the initialization section, we enumerate all the different codecs, and you can also do more yourself. There's a register media codec call that you can call. So if you have other formats that you have a codec for, you can register those codecs to FireMonkey as well. But I think in yours, are you just using MP3 files everywhere for audio?
I used WAV files for the sound effects, and then the MP3 file for the music.
Okay, great. All right. And again, I tested the audio on all the platforms that we supported when the games were first come out, and everything was just fine.
So there's a question here about discussing the calculations for physics, movement, acceleration, inertia, and thrust along different axes. So they're kind of just basic calculations that you use some of the math functions that you use cosine and sine, I believe. But if you go to that EmmanuelFerrento.com site, there's all kinds of tutorials on there that show you the math to do all those kinds of things. Yes, you can look in the games and see how I did the math there, but those tutorials will explain like all those different calculations. Like inertia is you're just adding a number to another number, and then you slowly over time in the game loop you just subtract it. And so that's basically the inertia calculation there.
Yep. Have you done anything, maybe this is for tomorrow, but I'm not sure if you're connected with, I think it's SpriteKit on Mac and iOS. Have you played around with those at all? Those lower level?
I have not. I know that TMS Software has a SpriteKit. I forget if it's a free library or a paid library, but they have a SpriteKit integration. They did a Christmas demo that has a snowflakes using SpriteKit on iOS. And I believe that demo source code is available for you to use.
Yep. Let's see. Let me go down. Are the games available in binary form so we can deploy them? Have you put the games up in the Apple App Store or the Google Play Store, Eli?
I have not. Yeah, they're not really available in binary form. We'd have to do that.
Okay.
We looked at putting them up, and all that stuff requires having the signatures and all those kinds of things to sign it and then get it approved and that kind of thing. So these are mainly for other people to grab the source and compile it themselves using Delphi on all those different platforms and play them that way.
Yeah. Let's see. Did you ever use Game Circle from Amazon or in-app with Kindle? I don't know those. Game Circle.
I'm not. Game Circle sounds familiar. No, I don't think I've used it. I've used lots of other libraries. Not particularly that one, though. But I do have some games on Amazon, but I don't think I used those libraries because they weren't multiplayer or something along those lines. But if you want to use all those other third-party libraries, all the app libraries and all the whatever else that is available on all those platforms for all the games, there's a couple different tools you can use. There's SDK Transform that ships with Delphi Berlin, and you can use that to take the iOS frameworks, even third-party frameworks, and convert them to Object Pascal so you can add, access all their framework code. And then for Android, there is, with Delphi Berlin, I forget what it's called, but there's a Java tool that will convert the Java code to Object Pascal as well and allow you to access those libraries on Android. And then on Windows, of course, it's
Well,
just
go ahead.
DLLs and API.
Yeah. It's for Android, it's Java, the number 2 OP. I think if I remember correctly, I'm
Yeah, that sounds right. Java 2 OP.
Yeah, Java to OP. I scrolled past it. And then it might be under Tools, and then, well, I'll post, STK Transform. There's a batch file and an executable. It's in the bin folder, so folks, you can look for program files x86 and Embarcadero Studio 18 bin and find what you need. Okay, let's go back. I don't know, Jim, you're on with us. I don't know if there were other questions over in YouTube or Facebook land. There was a question about high score information from one device to another, from one iPad to another iPad. I mean, right now you're saving the high score locally, right?
Right. Currently, the high score is just locally. Yes, you could add either through app tethering, you could tell the high scores to go back and forth. You could use T-REST client in Pro or higher to send the data to a server. I'm not sure if Indy comes with Starter, but if Indy is in Starter, you could also use whatever, either TCP or HTTP clients to send the high score data to a server and aggregate it, and then you'd have cross-platform high scores. And there's all kinds of high scores libraries too. Like that's one of the things that lots of third parties provide for the different platforms is high score libraries.
Yeah, I wanted to mention that I've added day 3 video. Jim uploaded it. I've added it to the playlist, and we'll get day 4 up there as fast as humanly possible as well. I'm trying to find that link to that math tutorial site. There's another question. Maybe you can paste it in again, Eli. There's a asking for it again.
I pasted in the link to the game development resources.
Oh, there it is. Okay.
Slide. And so that just has all kinds. I mean, he's got like, I don't know, 859 game design blog posts. He's got 179 blog posts about Box 2D. He's got all kinds of other, there's like 150 different game styles that he has a tutorial of how to build that style, and it's just a basic, this is how you put together this game loop or whatever it is to create this kind of game, and you can easily translate that into Delphi. And so then the best part about it is that even with these games, you already have all the menu stuff set up, and you can just change the functionality of the game, and all the menu stuff is set up. So with some of these other tools, like if you do HTML5 or something, you still have to go build all the menus and things, and that can be where people get bogged down because they're like, okay, I've got this game, I'm kind of playing it, but in order to turn it into a professional game, you got to build all this menu stuff, the sound on and off and all that kind of thing. And so with these game sources, you can just grab it and go. And so that's one thing that makes it easier. I mean, it's got all kinds of balloons here, blockage, circle path, diamond digger saga, all the different tutorials on how to build that kind of game, and you can easily translate that code over into Object Pascal or C++ with C++ Builder.
Okay. For feature suggestions, people are asking about future plans and features they'd like to see. Just add those feature requests into the quality portal, quality.embarcadero.com is the best way, or if you find a feature request, vote for it, because product management looks for the feature requests and the votes as part of the business planning for future features. You can also check out Marco Cantu's August 2016 roadmap update. It talks about the Linux server support we're working on. And Marco also did a blog post a couple weeks ago, or at least last week, on the Linux 25th anniversary, and has a short video linked in there for showing building and deploying a console application to Linux compiled with Delphi. Again, we're doing server-side and console applications, not GUI or FireMonkey for Linux. That's not in the current plan or current roadmap. There's a question here about whether you are using any kind of geospatial data structure for objects in the game.
Not that I know of.
Yeah. Okay. All right.
So when the Linux version comes out, you could easily use that to create the high score server, and then you could aggregate all the high score information through the Linux server.
Yeah. And you can use Indy. You could grab Indy independently. You can use that with Starter Edition. So you could do things like TCP and Gopher and HTTP puts and gets and so on. There's a question about use ttimer versus the parallel programming library as an alternative. Was there a reason why you use just a main loop and a timer versus the PPL?
Mainly for simplicity. You could totally use the parallel processing stuff to reduce the game loop. Like if you just had more objects, lots and lots more stuff, you could totally use the parallel processing to reduce the cost of the game loop, or just offload it to the other threads. So yes, you can do that for just demonstrating the games and ease of that. I just use ttimer. It just allows other people to jump right in and start making changes without having to think about some of the parallel processing things that make it more difficult to think about.
Yep. Yeah, it's very simple. I looked at the source code and you showed it. I mean, there's just a big case statement, or in C++, the switch statement, right? And the main loop just runs looking for things to do. Okay. Somebody else? Go ahead.
You can add all kinds of different functionality. Like you could have the player character rocket shooting multiple projectiles at different angles. You could turn the points thing into a power-up thing, so you can collect different power-ups and get more bombs or more lives or whatever it is. So it's set up. That's why all those different pieces are in there. So yes, the points power-up, all it does is give you more points, but you can easily add a switch statement in there and use tag or something like that to tell it which kind of power-up it is, and then you can add a whole power-up system into these games really easily without much extra work.
Yep. Okay. There was a question over in the chat window about could you build a video using FireMonkey by capturing the frames, and the camera does capture frame, and there's an event handler called on bitmap ready. So when the frame buffer is full, you can hook that event handler on the T-camera component, and then take that frame, it's a bitmap image, and start building up your own internal data structure of a movie and then save that out. But we don't have a video camera movie recorder sample that I know of. I'll double check again, but I haven't seen one. Let's see what's happening over here.
Well, so with the video camera, I think you can use like the native platform recorder. So it just sends it out and says, okay, go use the default Android recorder and then send me back the video. And then you can use the video that way on Android and iOS. And then as far as recording on, say, Windows or something, or recording the screen, it would be very, I don't know if it would work, but you could use make screenshot on the form, and if you strung all those together, you'd have a video, but I'm not sure the performance would allow you to do it. Depends on, you'd have to try it and see if you could make screenshot 30 frames a second to record the form.
Yeah, for actions, just use the action list component, and there are a whole bunch of default actions that work with FireMonkey, like take picture from photo library, take picture from camera, and then there's event handlers on those actions for did the person actually take a picture, did they cancel, so you can do all of that. There was a question here about using Facebook to preserve games and so on. I mean, you could do REST calls into Facebook. There's a Facebook API. TMS Software has their Cloud Pack for VCL and FireMonkey, and it's got all sorts of components for doing, connecting to Facebook or Google Cloud, or I think they've got Dropbox and a whole bunch of other things, Twitter. So check out the TMS Cloud Pack from TMS Software. Alpha's mentioning that Meetoff Software has a set of components, audio lab, video lab. So you can check out go to Meetoff Software, mitov.com, and they've got a neural network library, so you can add intelligence, do artificial intelligence on applications you're building. So, I probably put that in the wrong. I posted the answer in the wrong for the Cloud Pack. That should be tms.com. Sorry about that, everyone. Okay. To get to TMS Software, it's just www.tmssoftware.com. And then for Meetoff Audio Lab, he's got all sorts of things, including an Arduino Delphi connection set of components if you want to do something that way from a FireMonkey app. So there's all sorts of stuff going on in the third-party world. You can go to tp.impartgadaro.com and then use the partner directory to search by category and by product the supporting third-party products that those partners keep up to date. Okay, I'm not sure about this one. Just came in about if you're capturing video, can you impose text on top of the video in real time? When the camera gets turned on and you see the video, that's in a video area. I'm not sure about putting text on top of it, but try it, Peter. I'll have to play with the example. I don't know if we've done things like with chyrons in the lower third on top of a video stream, but I don't see why it shouldn't be using layering and a FireMonkey, but I haven't tried it.
So with the FireMonkey Go game I was testing out, I did do like an alternate reality thing that Pokemon Go does have, and so I used the T-camera component and I pulled in the bitmap from the camera, and then it's just FireMonkey. You just put more controls over the Pokeball or whatever. I just put that over the top using T-Circle or something like that, and then you can just swipe it forward and it does it like it does in Pokemon. So that was one thing I tested out. So yes, in FireMonkey, everything is just an object as long as the video's in a FireMonkey object. Now, with some of the mobile devices, it can get tricky if you're using the native video, because the native video will want to float to the top, and so you'd also have to have a native object, which you can do in FireMonkey, but most of the objects are not native by default, especially on Android. So you'd have to use those native objects over the top. And as far as putting the video or putting the text on the video itself, that would be something different. I think if you use the make screenshot way, it would do that, because you would just get a screenshot of what you see with the video in the background and the text over the top of it. But I would say it would be pretty difficult to turn that into a video just based on performance-wise. You're taking screenshots every once a second or 30 times a second. So it just depends on the device, I would say.
Yep. Yeah, I know that I agree with you on the camera, on the smartphone devices. The camera wants to take control. But we do support some native components on some of the platforms, and the team is working on more native control support. I think, and the way you can use that is if you put a FireMonkey component, visual component on the screen, like a speed button or whatever it might be. There's a property that you can choose for whether it's a native control or it's a styled control. And you can tell, for example, like on an edit box on iOS or a T-Memo, for example, one of the benefits of that is you'll get cut, copy, paste, things of that kind. Is what you'll see is when you turn on the native version, you'll see a little iOS icon, for example, or a little smartphone icon inside of the edit box or the control that you put in FireMonkey to tell you that you're using a control. That's the control type property. So put a T-edit down. Your choices in control type is the name of the property, are either platform or styled. And so when you choose platform for the control type, it puts a little smartphone kind of gray bitmap in the right-hand corner of the edit boxes area to let you know that. You can do that whether there's actually native support on a platform for that control. FireMonkey will come up and say, oh, we don't support native on that platform, and it'll just switch automatically into the covers back to styled. So, but on iOS, for example, a native edit would give you things like cut, copy, paste, cancel, and those kinds of things just by setting the native control. It also ties into the spelling correction, for example, if you have that turned on your iPhone. So take a look at control type as a property on the visual controls that are part of FireMonkey.
And there's all kinds of third-party ones that do it too. TMS has a whole bunch of native controls, and then there's all kinds of free stuff out there too. Pretty much everything you'd want, every native control you would want there, it's available via a third party as well if it's not built into FireMonkey.
Yeah, TMS is the ICL or iOS control library, so they've wrapped all, I shouldn't say all, almost all, or maybe it's all. So go to TMS software and look for the ICL.
And they also have an MCL, which is the Mac components.
Okay. Yeah. So
just a game idea for people out there. So if you could take one of my favorite games is 1942, and you could easily turn the Space Rocks game into 1942 by just changing the background so it was scrolling and changing some of the enemies so they're falling from the top of the screen, and then the player can only move back and forth at the bottom of the screen or all of the screen. So that's just a game idea that you can easily modify any of these games to be some other kind of game very, very easily.
Yeah, I put the link to ICL from TMS and also the Cloud Pack in the chat window. You can go and grab it there, and then here, let me find the MCL. There it is. Oh, MCL for Mac, right? Native Mac development. So I'll put that link in the chat window over here. Too many windows open in front of my face. Okay, and there's the link in the chat window to TMS MCL. Okay, I was trying to figure out if Jim, I know you're on there, but he's also been battling the Facebook and YouTube streams. It seems like we were maxing out live transmission bandwidths when you were showing the full screen using a camera of the play versus slides and code. Jim, any other questions that were coming over from those other streams?
Actually, I think all the questions that came on the other streams you covered in the GoToWebinar stream, so that was good. Okay.
Eli, any last words? I mean, the source code is there, so have at it. Anything else to add at the end here?
Yeah, interesting to see how people change the games and publish your work up on GitHub. If you make some changes, if you build 1942, publish it up there so I can play it.
Actually, I do have a question for you, Eli. Are you going to share the source code for your FireMonkey Go?
Sure, I'll send that to you.
That would be cool. And didn't you make a mock-up of Ingress as well?
I did. Up on fmxexpress.com, there's an Ingress mock-up. It actually uses like the Google static image map API to pull in static images and show it in 3D. It actually uses FireMonkey 3D. Shows it in 3D, and it rotates around and has some 3D objects on there. And so in this FireMonkey Go thing I was playing around with, I actually was more concentrated kind of on the alternate reality part, the camera part, and then I was just using the regular, so far anyway, just using the regular map, 2D map instead of using that 3D map. But I should probably switch back to the Ingress style map because that's closer to the FireMonkey or the Pokemon Go way.
Yeah, for those of you that haven't gone to it, you should absolutely bookmark fmxexpress.com. It's Eli's portal where he puts up everything that he can find that people are doing, including himself, with FireMonkey. So there's links to all sorts of articles and samples and components. I think one of the cool things you also did, Eli, is I think you built TrollEdge, which is an editor built in FireMonkey that runs on multiple platforms, programmers type editor. Is that right?
Right. So TrollEdge is kind of it just allows you to open a whole bunch of different file types, kind of like a text editor, but it also has syntax highlighting. It also does some code completion for Object Pascal, and then it also runs on Mac. So you can have Mac and Windows version. And so the reason why you have the Mac version is because if you're over on your Mac with PAs, pulling all these iOS apps and stuff, you can use TrollEdge to open up the files. You can open up zip files and just view inside the files, and it's pretty cool just to use it as a utility to access all the different files, view images of inside the different folders of all the iOS apps and things like that. And then another thing that's over on fmxexpress.com, if you ever remember Flappy Birds, which came out a couple years ago, maybe last year, I did a FireMonkey version of Flappy Birds, and that source code is also on there. So that's a 5th game you can download and try out if you want.
There were several questions about some of the tools besides Delphi you used. One for the sprite sheets and another one, I think, for the mountains on Rocket Ship Delta.
So I use Adobe Flash for the animations, and then like a lot of the graphics for other people did those, but they created them in Adobe Flash. And then the logos here, those are just different fonts that I used. And that's why they look the way that they do, so they're all stylized. And then some of the stuff like the Space Rocks font, that one that's got a glow behind it, and that glow, I'm pretty sure I used Adobe Flash to do that. Same with this Alien Invasions, it just has a bevel on it. Most graphics programs offer that kind of bevel feature. Mars Rock has a similar bevel, but mainly it's just the fonts, that's how it created those styles. And so the mountains in Rocket Ship Delta actually use Bryce 3D. I think the latest version might be 7 or something like that, Bryce 7 Pro 3D, something along those lines. And so Bryce 3D it's kind of a 3D landscape creation tool. I mean, it does all kinds of other 3D stuff too, and it's tied into Poser, which does people. But it was really easy to create that mountain graphic. You just drop in I think there's a free trial too. You just drop in a mountain and pick a texture for it and render it, and you're done. So lots of the tools that I like to use, they're very simple to do. And same with the animations with Adobe Flash. You can just easily animate stuff and then export it as a sprite sheet to load up in Delphi. And there's even plenty of free sprite sheet generator programs, because sprite sheets are very commonly and widely used in game development in most of the tools that people use on Android, iOS, and Windows and things like that. So there's lots of free tools out there too to create sprite sheets, or if you already have sprite sheets, you can just get them into the correct format and they should work in Delphi as well.
I like how you also showed using the rectangles to show how the prototype started even before the graphics were laid over, right?
Right, and so, I mean, that's an example of, okay, you don't really need the graphics to start out. All you need is the functionality. Once you've got the functionality going on, all right, then come back and skin the graphics. You don't have to wait to build functionality, wait on the graphics or anything. Just get the functionality running, and then you can move forward with the graphics when you have them.
Then there was something somebody mentioned about, I guess I don't know if you were loading a stream file or something. They were getting an exception with Rectangle 2.
All right, so in some of the in 3 of the starter games, which I think is Mars Rocket, Rocket Ship Delta, and Space Rocks, if you're loading it up in starter and you get a message that says Rectangle 2 is missing, and it asks you, do you want to just delete Rectangle 2? I think if you hit OK, you should be able to just compile the games when you do that. I tested that over here. I'm not using Starter Edition, but I tested clicking OK, and it accepted it, and then I was able to compile without any issues. We're going to get updated versions up on GitHub that won't have that issue when you first start it up either. And another issue that there's an issue with T-grid panel layout. If for whatever reason it corrupts, this mainly happens in Mars rocket, for whatever reason it won't compile. If you just either just restart the project, reload the project, or if that doesn't fix it either, you can just unzip a new version and it should fix that. It has to do with there's an issue with the Delphi IDE. It doesn't like T-grid panel layout in some cases when you switch platforms and stuff.
Okay. And then someone asked how much of the code was reused across the games?
So quite a bit of the code is actually reused. The frames, like I created Alien Invasion first, and then I think, and then I just reused a lot of the code between all the games. So the frames themselves, are all those interface elements, those are basically the same across the 4 games. I believe the gamepad frame is different across the 4 games because in some of the games there's different buttons, like Rocket Ship Delta's got 3 different buttons, and then the left and right and up and down buttons, those are all kind of different between the 4 games too. So